Okay, today we work on one important feature. This feature is JUnit XML report format, which will allow to integrate the output of our testing library with already existing tools like Jenkins or whatever. And luckily, we even get paid for this. That doesn't mean that I earn 5 grand in an hour, but after we accomplish this task, we can send a request for payment and get money from the grant I got for this particular library. So, to make it clear, probably I spend a bit more time than 1 hour to get to the point where I can implement this functionality relatively quickly, and I hope to accomplish the most of this milestone in the next hour or two, and it probably will take a few more hours to clean it up, but the clickbaity title is kinda truthful, but still clickbaity. Okay, you as usual can write to the chat or to the IRC channel. I read it from time to time, and let's start actually implementing the stuff. We have our reporters, and we have actually let's start from creating a model which will contain the tests, and we will write a few tests, and after that we will make an implementation. Otherwise, why we would do this testing library if we don't use it? I will just take the same stuff and will put it into reporters test SCM. We have almost all the necessary models imported already. This one will allow us to define tests. This one will allow to test the test runners that we probably don't need much, but maybe we will need. Yeah, probably we will need it. And this one will contain the utility functions for the reporting. So let's start from defining a suite. This suite will be JUnit XML tests. And the first test transform run results into a list. Let's call it JUnit a list. What it will do? First of all, we need to get the results of test execution, and it will be some data structure, and we need to transform it to the data structure which is SXML, which will be SXML, I guess. So the XML represented in S expressions or just nested lists and stuff. How we obtain the results, test results? We can just create the data structure, how it should look, but I think the easier way will be to just execute the real tests which will produce this data structure, and it should not take too much time. We will just copy paste those helpers in the moment, and we will put them to a separate model later, because we already use it in a couple places, and probably it will be useful in a few more. the silent test runner is useful. Define test runner silent runner because it doesn't like make a noise, which is good, and we will be able to do this test runner tr, and here we will define a suite, and inside suite first suite we will define a test. Good one is true, is 1, 2, 3, and one more failing test, and it will had a failure and probably an exception. Like this. TR. Boom. You can see unspecified value, which is expected. Now we would like to extract the information from a test runner. And this information is already stored in a state of the test runner. I also did like quite noticeable refactoring for the test runner. You can see the arguments changed. Now we have a config and default config, and this config will override those values if they're present by actually just merging two lists. And for merging I do a basic append, which not actually a merging, but for most operations it will work as a merging. Maybe I will change it later, but probably it will require a good persistent data structures for better implementation. Anyway, we need to obtain the data about our previous test run. And how we get this data? We can get this data from summary. Get run summary. Like this. Do we have a special function which returns? Yeah, this one. This function returns a summary of the run. So we can either use tr or we can use test runner asterisk, which are basically the same. Tr type runner get summary, and also let's print it for now, or maybe we'll print it like this. Good. Actually, let's load this test. And you can see that when we rerun, we see, let's actually load all module tests, and when we rerun it, we should see this one more time. Why I rerun it and it doesn't say anything, doesn't print anything. Oops, I guess we have a small problem here. Oh, okay, it works now. I forgot something. Yeah, it works. Yeah, we don't have any problems. Very good. We have run summary, but it's not enough. We need a more detailed thing, and this probably should be a run history or some kind of this thing. So we don't preserve this information yet, I guess. Okay. Let's save this information. By the way, are we healthy? Yes, we are. Okay, inside the tests, you can see that we have test execution results, but we don't save them anywhere. Let's add the execution results. Let's print them. Maybe it's not the best idea, but let's see. Oh, it looks like an empty list. Oh, because we don't have any tests loaded. Reporters. Okay. Run test. What run test returns? We don't have enough information here. Run test should return more info. Run test returns only this thing, but it also should return the test itself, because it contains very valuable information for us. Let's see if something will break if we do so. I guess it can be broken. Way we merge summaries. Summaries. Lambda v match v the value blah blah blah. Oh, so we go. So merge run summaries should work quite well. Yeah, it should be good. Oh, nice. Now we have this information, and we can store it. By the way, our run summary at the moment is atomic, but we don't actually need it. If you noticed from the previous time, we had a different variable for atomic box, but now it's inside our state. But it should not be atomic box anymore, I guess. Run summary doesn't contain much. Run history. and this will be an empty list by default, and we can set the run history to test execution results. How we do so? Do you remember? I guess it will be atomic box update. No, it will be update atomic list value. State runner run history and function lambda. We ignore the value and set the value to test execution results like this. So that's basically it. And now we need a new function to obtain this value. Get run history, and this one will do state atomic box ref sock ref runner and history like this. And now let's evaluate all the stuff. Still works. Let's go to our tests, and here instead of run summary, let's take a run history and let's execute. Now we have a run history. Actually, let's take a look at what we need to get as an end result. We need to get something like this. Okay, probably we will need more information in our test history. To maintain this stuff. But okay, we can add it later. For now, let's just transform this thing. What I'm interested in at the moment. At the moment, I would like to have this stuff. And then extract surfy. I want to extract the first value, and from the first value I want to extract test. The test will look like this. At data body. Here we probably would like to attach not only the number of assertions and tests, but also the results for each assertion, but we will do it later. Actually, the format that we output the format of history we collect can be covered with tests in runner's model. But okay, now let's extract ref suite pass, and let's see what we have here. Parameter. Why it's parameter? Okay, what if suite suite it's still a parameter which contains only one function? It seems a bit wrong. Okay, we probably save suite pass incorrectly. Suite pass. Oh. Okay. Now we are good. Okay, now we have two procedures as a suite pass, which is very nice, because originally I was saving not a list, but a parameter which contained the list. Now we are good. And you can see that this procedure is the same as this one. The only problem with suite pass that it in the incorrect order, so we need to reverse it as well. Reverse. Unfortunate consequences of using lists, but it's okay. Now this procedure and this procedure are the same. What we can do with it, we can group by our test results. by the suite path. Do we have grow by in scheme? Grow by Guile scheme. Doesn't seem right to me. Okay, we have a list cons surfy one selectors. Split at take drop last. Nope. Partitioning. Span. Unfortunate. Okay, I guess we will need to implement grow by ourselves. That's very sad. Function oh, let's just take a look at signature of closures grow by. Yep, it's function and collection. Okay, let's do a magic trick. Let's try to implement it with LLM. Returns a list of lists how the format of grow by should look like. Returns in a list where the key is the result of f applied element of L. Good. Oops. the value is a list of items. Okay, I think it should be good enough explanation. And now implement the function. Will it work? The elements in the same in Okay, let's see how it works. Bad lad. Grow by. By see. I guess it's implemented it in Emacs Lisp. That's why it was the strange usage of let, and the keyword also the wrong one. Okay, now it looks like a scheme. I mean, the define is obviously already a scheme. Will it work? Okay, remove use models. Okay, let's see what it actually wrote. Reverse the result. existing. Rather at least cons key cons item cadder at existing. Looks right. Remove this is this is not right because it screws up the ordering. The way we can actually implement it by maintaining two things. We can have a hash table with lists, and we have a list of keys in the order they appears. By the way, preserving the order. I would like to preserve it, I guess. Let's see what it's wrote. In groups. I am a bit dissatisfied and frustrated by the lack of so basic function in the standard library. Maybe I missed something and there's like what the SQL. A horrible name for search engine. Okay, I guess this is incredibly inefficient implementation. I guess I can take this implementation and combine it with one more thing. I don't remember how this function called. What I basically need, I need to go through this list and build another list in the order of duplicates in list. Scheme language. Woof. Sounds terrible. Okay, what we will do? We will do define unique keys function and list. We will fold over the list, and originally it's empty list, but here will be lambda, which have arguments. Don't remember the order. Like, the interface is so inconsistent that I always forget the order. Element and accumulator value, I guess. I'm curious, for fold right it is the same? I hope. Okay, and what we will do? We will do incredibly inefficient thing, but if member accumulator, what we will return it. Otherwise, we will return cons element accumulator, but of course it should be not E but F at F from E. Let here calculated element here. Don't know why I should write those functions. They should be available out of the box. Keys, like, we will do the same. One, two, three, 1, 2, 3, and if we transform those two, 1, 3, 4, 1, 3, 2. Right. This is what I expect to get. Now, this thing that grows by, we will rewrite it because it's horrible. we have hash tables in scheme, right? Which hash table I should use? Make hash table. Is it Surface 13 or it's out of the box? Make I think there's some kind of out of the box hash tables. I guess it's key value. We will make result, make hash table. And they will be inversed lists because cons does like that's so stupid that cons adds to the beginning of the list. Why I'm so frustrated when you need to operate on data structures and schema. Like terrible UI. Terrible experience. Pam 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 pam. Let's actually do it. Oh, maybe we can do pam pam pam. We can ask our friend to do so. Actually, it looks about right. Maybe it's not hash table update. Result key. Oh, actually there's such function. Key modifier. It's Surface 69. I'm curious. We have so. We have it. Of course, nobody returned result. And also what we need to inverse all the keys. Table update, table set, table properties, creating hash tables. Paste to hash table. Placing table values. Okay. Table walk lambda key value reverse value. So painful APIs. They compose so horribly bad. You can see, but the muscles on my back are like exploding from tension. So incredibly fucked. Table set result key reverse v group by to hash group by to hash. Boom. Wrong type to apply. What the fuck? Key v. What was this empty list here? Key not in a table. What the hash table? Alt key. Otherwise hash table set result key v. Where is v? Okay, it will be x. List x. Almost complete the implementation. Key not in table. What? And now what? Table key default. So inconsistent. Answer the value associated with key in table. If key is not present, answer the result. Car. Count variable car. What? Okay. Hash table. I will cry. The hash table walk accept the hash table first and the function second, while maps, folds, and all other functions accept the data structure first. Last. Okay, okay. And now can we hash to table to a list? Okay. 1 3 2. Oh, surprisingly it works, and surprisingly it ordered the same way, but I guess it's not guaranteed to be ordered the same way. This is why we will need this function. And after we will do define group by fl, which will take all the lists. Of course it should accept, and will map. Also we need a hash table. Grouped hash, group by to hash fl, and here lambda key we will do hash table ref group hash. Ooh. Okay, let's see. Almost. The last bit. We implemented a group by. We just spent 1 hour to do so. Amazing, wonderful. But don't know why I must spend so much time doing so basic thing. Okay. Now we need a simple transformation of our test history, of run history, into the data structure similar to JUnit. How we will do it? We will do it with group by, of course, and ideally it should be done recursively. Oof, it will be so terribly inefficient. I feel almost physical pain from manipulating data structures and scheme. It gives me feeling of anxiety. You know, there's like a feeling when you're expecting something good to happen, but this is completely opposite. It's a feeling that you will suffer hard doing a very basic things, and there's no workaround to it, like implementing other language, but it will take a bit more time. Extremely frustrating and unsatisfying. Okay, I will explain what I need. Oh, actually, it still feels painful. Let's see what the return value is. Oh, for some reason I hanged simulation somehow. Okay, whatever. Nice. We have this run history. Let's save it to the variable actually. Define tmp and let's set tmp. Let's create the runner and let's do this thing. And now inside tmp we have our history, and we can do grow by some t function tmp. Now the t function will accept a result and will assoc ref will chain. I think I need a separate streaming PC so my laptop don't get extremely hot and laggy. Assoc ref actually it should be define ef chain r assoc ref. What I'm assocking, I need test, and from test I need assoc ref sweet pass first element of the pass, because we need, you know, all the tests which are inside this suite. Yeah, that's right. And what grow by will return? Let's see. Grow by a return procedure. Inside this procedure it return list, and this list contains 2 tests. And now the next time we will need a different suite pass. That means that if we have 2 procedures in the test in suite pass, and here we have only one, like this. This test is a part of this suite, but this test is a part of a nested suite. So we can group by this list one more time, but this time we will do it by the second suite path. And here, this one, okay, I will show you. Chain this thing. We will group by. We will map, and inside the map we will do, how we call it, group by second path, and like this. And here group by second will accept a list, element of list, right? Oh no, it will accept list. All right, it will accept list, and we'll do group by another function and this list. And this function, the naming is wonderful, you can tell. Let's name it actually a bit better. Get second suite, second from suite pass element, and we have element, we do a sock ref element underscore test sock ref underscore suite pass, and here we do header yes. Or what if we have only one element? What it will return? Acting pair. Header. Define header. This is so bad. Oh. This is like extremely bad. What if I do drop list one, drop two? Okay. Maybe second if length of list like this. Okay, length of L. Okay, it got F. Why it got F? Maybe seconds with pass test for each. Okay, the procedure that called MB second. What did you get? What? Ah. Wait a bit. Group by second from bit. It's a function that takes element of the list. Yep. That's right. This is association list, and we go through its elements, and this one. Okay, I guess we need to take color from this list. Nice. Oops, I screwed up a bit. Okay, did we group it? Yeah, yes. You can see the procedure here and F here. F means that this test belongs to the test suite where it is, and this test belongs to the nested test suite. Okay, we kinda get this recursive stuff. Of course, it should be fixed and not like a second one, but like nth one, and we need to make it a recursive call, not like one level call. But the overall direction should be clear, whatever. I'm really hungry right now and really tired, and unfortunately we didn't got our JUnit XML representation for our test history, but at least we saved the test history and we wrote a few helpers to operate on data structures. Whoa. Yeah, I think it will require a few more hours to finish the implementation of transforming this data structure, and I think that producing XML from the final data structure should not be that hard. We already, you can see you can do a lot of things and almost got the tree which represents the almost similar stuff to JUnit. Okay, that means we don't get 5 grants for 1 more hour of our work, and we will need a few more hours of work. But this was a good title, and this was a good stream. Thank you everyone who joined and enjoyed it. See you in a bit. Bye.